Hello, everybody. I'm Rafael Mendiola.
I'm Kyle Rosenberg.
We're design systems engineers at Hinge Health, and we're really excited to be here at Chain React. React Native has been around for nearly a decade, and many companies now face the challenges of managing mature, long-lived code bases. It'd be really good to hear some talks about that. Good news, that's what we're discussing today.
We're here to talk about design systems, a discipline that not only includes design and engineering chops, but also people and operational skills.
One of the biggest challenges of creating a design system is getting it adopted into the code base. That's hard, and it isn't talked about enough in the design systems community.
So we're going to share our story of how we went through and solved these challenges of efficiently implementing a design system into a large React Native code base.
Why should you listen to us? Let's give you some background on who we are. I started out my career as a Flash developer, and I'm really attracted to the intersection of design and engineering. I've been a React Native developer since around 2016, and I've worked with startups, scale-ups, and large enterprises. I've been collaborating with designers implementing user interfaces for a long time, and I've been advocating for design systems since the start of my React Native career.
So I'm a little bit newer to React Native, official React Native. I pretended to use it for about 5 years using React Native Web when I worked at a certain bird-themed social media site. We were using it to power our progressive web app. And that's also where I became interested in this field of design systems and UI platform work. I'm a longtime fan of Storybook, if you're familiar with that. I really love working on the developer experience and tooling side of things with design systems. So it's been really fun to take that experience and apply it now to React Native.
We have a lot to go over here, so here are the things that we're going to be discussing over the next hour and a half.
So we're going to tell you about the two main projects that we worked on, Hinge Health's React Native application, which we called Phoenix, and Heal, the design system that we built for it.
Then we're going to take you through the cross-disciplinary challenges of implementing a design system, including
how we built the design system for our React Native application,
the steps we took to accelerate our understanding of a large code base when we were going to transform,
how we aligned our stakeholders when their expectations differed from ours,
how we created a detailed migration plan to replace old components with new ones,
how we drove large-scale migration ourselves to avoid impacting the velocity of other teams.
And after going through the challenges, we'll talk about the benefits that emerge after fully adopting the design system.
And then we'll end with some takeaways that you can reflect on as you think about your own projects at work.
We hope to provide you with a fresh engineering perspective on design systems and present you with practical strategies that inspire you to think creatively and more ambitiously. Thank you for joining us, and let's get started. First, let's talk about Phoenix and the Heal design system. Hinch Health is a digital clinic that offers personalized pain care for individuals and organizations. With the Hinch Health app, you can benefit from exercise therapy, connect with your care team, and learn more about various joint and muscle issues, including pelvic health. Our application is available to millions of members through their employers and health plans. Phoenix is the internal name for this mobile app, and it's a very extensive React Native project. It has everything from physical therapy exercises that make extensive use of computer vision algorithms, to video calling and messaging systems, connectivity to medical devices, educational resources, and there's some even games in it. It's a very busy repository. This project has been active since 2018, and in the past month, around 90 different contributors merged over 350 pull requests into the codebase. When we joined, Phoenix already had reusable components, but they weren't quite standardized the way that the company wanted them to.
So Heal is the design system that we built for Phoenix that we worked to build with our design partners. A design system typically includes a component library, but it's also a lot more than just that. It's a coordinated set of design tokens. It has documentation, processes, tools. And its purpose here is to streamline the workflow from design all the way through engineering. It's part of improving a company's operational strategy. So our goal with Heal was to, of course, speed up development and help designers and developers feel confident about what they're building. that ultimately leads towards making that app experience much better for the end users. So Heal's component library has about 50 React Native components in it, like buttons, icon, text fields, cards, and about 300 design tokens. Design tokens are those foundational elements like color, border radius, spacing. And today, Phoenix uses over 5,000 instances of those components and tokens from Heal. For developers, we provide the Heal component library as an internal NPM package. And for designers, they have the same set of components and tokens, but in their Figma library. Heal components are documented in Storybook for devs and Zero Height for designers. And the system also has processes for things that it follows, like building new components and supporting teams.
Let's get started on the challenges that we face in implementing this design system. How do you set up a design systems project for a React Native application? We decided to create Heal as a separate project from Phoenix. As we mentioned earlier, Phoenix is a very busy repository. We could have included Heal in Phoenix, but having a separate repo seemed like a safe bet since we didn't have a contribution model in place. We wanted to have a separate repo, but we didn't want to maintain another React Native application just to preview components. Instead, we created pre-builds of the Phoenix app by writing a script to zip up iOS and Android builds, and we used those pre-builds to develop Heal. Had we created a new React Native application for Heal, it would have been tedious to make sure that Heal and Phoenix are exactly synchronized. Phoenix uses a lot of third-party modules, and our infrastructure team, shout out to our infrastructure team, is really good about keeping Phoenix up to date. We did not want to deal with the overhead of maintaining a new React Native project in this environment. Creating the pre-builds also gave us the benefits of really fast launches. Since we don't need to build an app, our NPM start scripts are very snappy. The way that we created the pre-builds was fun, but a little primitive. In the long run, it would be great to set up our Phoenix project to use Expo pre-builds, and then we would be able to use the Expo Orbit app to use the latest Phoenix pre-build as we develop Heal. Another thing that we did to optimize our process was to use React Native Web and Storybook. This had a lot of benefits for us. You're all mobile developers, and you know that looking at a component library on a mobile screen is really tedious. What is this, a component library for ants? We work on laptops. We publish our Storybook to web, making it easier for developers to explore and interact with components directly in their browsers. No awkward navigation to a debug screen needed. We also use CI to post a staging instance of Storybook on our PRs, which makes it straightforward to review changes without needing to build a mobile app. We actually did the majority of our React Native work on web. If you're using React Native, it's awesome to be able to build on web with the guarantee that your code will work on mobile. I recommend that you really take advantage of this just in general. We didn't need to fire up the simulator that much. But we always did verify on mobile before publishing changes to the library. Once we created the Heal repo, we started making quick progress towards building Heal components, but then we started asking ourselves, are these components going to fit into Phoenix? Think of the app as a motherboard, and a usage site, a component usage site, as one of the sockets in the motherboard. If you want to put a chip in the socket, the number of pins have to match. Similarly, the props interface between a component and a usage site needs to match in order for the component to do what's expected. So to figure out this question, we need to get a sense of how the existing components in Phoenix were used. We started digging around into the codebase, and we found components that were similar to the ones that we had in Heal, but their props were entirely different, and they were much more complicated. This mismatch in components signaled to us that the success of the design system with Hinge Health on adopting it, specifically adapting all these component usage sites to work with the new Heal components. We started analyzing the code base by writing command line scripts, but eventually that evolved into our team building a more extensive component analyzer. The component analyzer is a web app backed by a node server where we combine React Scanner and ripgrep to generate reports about component usage. It gives us a much more intuitive understanding on the state of the code base. We use this tool to track the specific components we were interested in. In the screenshot, we're looking at a report of the old Phoenix text component. It had 42 props and was used around 1,600 times. On the list of props, the number next to each prop indicates how many times that prop is used in the codebase. For example, style was used 807 times, bold was used 86 times. In this tool, you can click on each prop to filter the report to only show the instances that use that prop. Below the props, the tool gives us a file map that gives us an immediate visual understanding of the extent of component usage throughout the codebase. Underneath the file map, the tool shows us the exact code snippet for each of those component instances. In this example, we're looking at several usages of the button component. I would love to open source this. I think there's a whole category of code observability tools that could be built. So if you think this is useful to you or you think this field is interesting, reach out to me after the talk. This tool allowed us to get a better understanding of the complexity of the existing UI components in Phoenix. And let's talk about that for a second. The Phoenix components were in a pretty complicated state, reflecting years of changes, and they had low developer satisfaction. The fact that the components got into the state is not an indication of poor engineering, but rather a symptom of the success and rapid expansion of the company. When a startup enters that scale-up phase, there are lots of different pressures that create stresses in the codebase. There's the urgency of delivering new features, there's shifting priorities, there's team reorganization, there's the changing of design standards, etc. Eventually, there was a gap between the design specs and the components in Phoenix, and that was hard to ignore. And that was causing friction in the collaboration between designers and engineers. So the design system would solve that. Once we understood what was going on in Phoenix, we started focusing on the problem of adoption.
So the direction we wanted to take with this project was a little different from what our stakeholders had in mind. So we were all kind of generally in line with this whole concept of building components, but their definition of adoption was really just limited to using those components in new product development only. Our definition, though, included integrating that system back into existing code as well. So after acknowledging that difference in expectations and coming to this mutual understanding of what adoption meant, we needed to prove that the value and benefits of that full adoption cycle were going to be worth the investment. So we shared with them the idea on how introducing a new system without cleaning up the old stuff would lead to this problem of competing standards, as famously depicted in this XKCD comic, and how the most recent app rebrand effort that we had gone through had been kind of long and difficult due to just the lack of unified methods for styling and building UIs. So a fully adopted system, we told them, would lead to improvements in UI consistency across the whole app. It would reduce cognitive complexity and decision fatigue for developers, which could speed up product development. That next rebrand, which had been in the works for 2024, would be a much less complex effort. So at this point, stakeholders wondered who would take on this work of integrating the Heal components into the existing Phoenix code base. We argued that it should be us, the design systems team. In order to carry out that plan effectively, it's going to take a dedicated team and dedicated time to dig deep into this and craft a very effective strategy. There'd be a lot of upfront investment and building tools, and a dedicated team could be sheltered from the pressures of product teams who might have otherwise gotten distracted from their product work and shipping high priority features. So next we had to align on how we'd measure our progress and track success. Our leadership originally wanted us to just track the number of components built and that were available for use. But after talking through this idea of full adoption, we settled instead to measure the number of Phoenix component instances that had been replaced with Heal components in the code. So we already had a tool that Rafael talked about, the component analyzer, to make counting these usage sites easy. And then we expanded the capabilities of it to basically count any component, whether it was a Phoenix component or a Heal component in the code base. So we report this metric out every week to show our progress, and then use that metric as a key result measurement and part of our team's OKRs. Our goal would be to achieve 80% of adoption by the end of 2023. So getting this stakeholder alignment gave us a lot of confidence, knowing that we're all on the same page and we're excited to actually put this plan into action. So speaking of a plan, let's take a look at kind of how this plan actually worked. We used a series of milestones to track the adoption, which you can see along the bottom here. We have, build the component, integrate once, release, for GA, integrate everywhere, deprecate the Phoenix component equivalent, and then delete that once it's not being used anymore. So the lines on the graph here give an idea of how many of those instances of a Phoenix component and its heel replacement would change throughout these milestones. It's mostly an inverse relationship as those heel ones replace the Phoenix ones, but it gets slightly offset by the fact that some heel components are being used not just to replace the Phoenix ones, but there are net new instances going in new code as well. The curves just after that integrate everywhere step could look a little bit different depending on the component and the migration approach for it. And we'll talk about that step in a minute. But first I want to call out two different milestones that involved interacting with some really important stakeholders, which were product engineers. So first, this step of integrating a heel component once. It sounds a little weird. I can tell you why we did it. This was our way of validating that what we built wouldn't crash and burn in Phoenix prior to opening the floodgates and letting anyone to use it. So to do this, we spun up a pilot program where we partnered with some feature teams and had them use it in whatever new feature they were building in Phoenix at the time. So they'd come back and give us a thumbs up, maybe file a bug report, maybe give us some feedback about the props API and how it could be improved. So that gave them the opportunity to preview the design system and later become cheerleaders for it. It also gave us the opportunity to verify that what we built makes sense to product devs. I also want to touch on the second to last milestone here, deprecation. In that time between releasing the heel component and getting to delete the Phoenix equivalent at the end, we wanted to make sure that no one tried to use that Phoenix one prior to us blowing it away. So we did this by ramping up restrictions gradually for engineers. First, we would deprecate it by adding the @deprecated tag as a JS doc comment on the Phoenix component. If you're using VS Code or some other IDEs do this too, product devs would see a little slash through all of those instances, letting them know it was going away. If they hover over it, they'd get a message and a link linking them to documentation about what to do with this. As we got closer towards swapping out all the Phoenix instances of that component, we would then turn up the heat. We'd use lint rules to restrict imports, and then danger.js, which is an open source tool that would run on PRs and basically yell at you if you tried to add an instance of that deprecated component. So at this point, you might be wondering, how did you actually convert a usage site from a Phoenix component to a heel component? So let's dig into what that looked like using everyone's favorite design system example that gets used in every design system stock, the button. So the Phoenix button had a whopping 59 props available on it. Migrating each instance of those to a heel button introduced this challenge of figuring out if the heel button would be visually and functionally compatible given all that variability and number of props on the Phoenix button. So as you can imagine, the heel button had a lot fewer visual variants, something we were proud of. And so that meant we needed to figure out which of these variants and controls and inconsistency we'd be giving up. So first we had to know what we were working with. This part of the process involved just a lot of manual investigative work, going through basically each prop on the Phoenix button and figuring out, tracing it through the code, figuring out what it actually did when you set it to a certain value. So here's a quick simplified example. On the left, we've got an instance of a Phoenix button, and on the right is the heel instance that it mapped to. You can see some obvious differences when looking at the props. And if you look closely in the rendered examples below, you'll see one subtle difference on the button itself. So some of the props like onPress and icon stay exactly the same. The props API matched, great. But if you look at some of the others like primary and title on the left, you'll see that the syntax for passing those values is a little bit different. Primary, which is a Boolean on the left, becomes type equals primary on the right. And the title prop on the left becomes label, but the structure otherwise stays the same. Finally, the thing you'll notice at the bottom on the left is that style icon prop. It's not there in the heel button. And this was an example of an instance where we had to work with product and design to figure out how to resolve this discrepancy. We had decided already with our designer that we didn't want to allow the space between the icon and the text to be customized the way it was in this Phoenix button. It would make the component overly flexible and risk UI inconsistency, so it was intentionally omitted from the capabilities of the design system. But the important thing here is that pulling that ability would mean getting rid of a capability that devs were used to, but it would also be triggering a visual change when we went and migrated this instance. So when we ran into situations like this, we had to ask ourselves, is this a visual change that we're comfortable making on behalf of product teams? Or do we need to go add this capability back into the Heal component to avoid that visual disruption? So our designer and we kind of made those decisions together. Not all components followed the same path. Sometimes it went with the visual change. Other times we just adjust the Heal component. So all of these decisions, as well as mapping the props that we talked about, eventually it made its way into the Heal button migration guide for the example of the button here. This was a document that called out the visual changes that would happen when migrating an instance, as well as a big table that you see a snippet of here that basically said, if you encounter this prop on the Phoenix button, that means use this prop on the Heal button. So sometimes there were some button props that changed the function or the style of the button so much that it didn't really become a button anymore. And we didn't want to have those capabilities in the Heal button at all. So in those cases, the migration guide would call out, if you see no label on this button, that means migrate it to the Heal icon button instead, a completely different component. So this brought us to our kind of final challenge that we're going to talk about today. Just 3 of the components in Heal, button, text, and icon, and we were really surprised to find this out, would make up over 80% of all usage sites. So that's about 3,000 instances. And of course, we had no interest in manually swapping all these out. That did not sound like a fun way to spend our time, nor did it sound like a very efficient way, even with that migration guide. So to make it efficient, we brought out the excavators, AKA the code mods. If you haven't used or heard of code mods, they're an absolutely essential tool for something like this. Code mods are like find and replace operations with, usually using text strings, but on steroids. They're scripts that we wrote, so using an open source tool called JS CodeShift, and it can very quickly swap out code in your files by processing your code as an abstract syntax tree, or AST for short. So this slide here is a screenshot of the actual code mod script we used for button, although it's just the first part of it. If I showed all 500 lines, it would be very tiny. And if we go here, this should play a video. Yep. So this is running that code mod against a sample file in Phoenix. So we run the command, and then these panels show the diff after it's run. So you can see the code mod updated what component is getting imported at the top. There's a slightly different path and slightly different name. And then it adjusts the props on the button, similar to the example we saw a couple of minutes ago. And so we ran this on kind of all the button instances on all the files at once. And it's done in 5-10 seconds. So one last thing to note about the code mods. We included these code mod scripts as executables on the published NPM library so that they could be run from the app codebase with just an NPM command by anyone in Phoenix. This was our way of kind of sharing these tools beyond just our internal team. So as you might guess, these code mods were responsible for driving a huge chunk of adoption in Phoenix. But since they took a long time to write, the button one was 500 lines, other ones were a similar length, we only wrote them for components that had high enough usage to justify the cost. So for components with lower usage, we would revert to manual means, which did take more time. But if it's just maybe a dozen instances of a component, it's not worth that upfront cost of writing a big fancy code mod. Sometimes our team would do that manual migration, but other times we distribute it out to product teams and then point them to the migration guide.
I'm starting to get hungry. Hungry to see how adoption went. Let's look at some numbers. Here's a chart of how the last year or so played out in terms of our adoption progress. Using those code mods early on meant it only took us a couple of months to hit 80% adoption in Phoenix. In terms of absolute numbers, that represented over 3,000 instances of Heal components getting added to the code base in that time. We felt really proud of that achievement, and I think we surprised a lot of people with it, not just because it happened so fast, but because we did it kind of quietly. Walk quietly and carry a big stick. The code mods let us transform the code base literally overnight. For example, we replaced all instances of the icon component in one PR, and there were hundreds of them. Today, we sit around 95% adoption. We're at a little over 5,000 instances. While the metrics themselves are worth celebrating, reaching this level of adoption unlocked other kinds of impact.
So earlier in the year, the company went through another visual language refresh and rebrand, a similar effort to the one that had happened the previous year. But it involved changing the typeface, new fonts, introducing a new set of semantic typography styles. And because of the fact that all the text in the app was, at that point, was being powered by Heal, it made that transition really quick and seamless. We've also been seeing noticeable improvements in UI consistency and the speed of writing UI code. One example that you can see here on the right is the confirmation dialog UI across the app. So prior to our work, this pattern here of presenting some text and some buttons in a modal had never been componentized, which meant there was no Phoenix equivalent of this component at all. So designers and developers alike, each time they wanted to use this sort of thing, would reinvent the wheel and basically write code or build up a new design in Figma. And you can see a lot of inconsistency here. Sometimes the text is left aligned. Sometimes there are 3 buttons. The order of the buttons isn't always consistent. So by building this pattern into a Heal component and then actively swapping out all of these dialogue-like UIs, we not only made all those experiences look better and behave more consistently, but we also made building dialogues a breeze for devs and designers by componentizing it. So last thing, getting to this critical mass adoption meant that there's a good chance today that any TSX file that you look at in Phoenix imports at least one component or token from the design system library. So we've definitely spread awareness of the system by other means, but this prevalence of the system means that developers working in code are used to seeing Heal everywhere. And it's become the de facto way of writing UI code now. So compared to those earlier phases of adoption, we're now seeing many fewer cases where developers are just building their own thing or trying to use something that's deprecated or on its way out. All right, we're getting near to the end of the talk. I wanted to acknowledge some folks that worked on this project with us. We're really grateful to them. We didn't work on this in a vacuum. So thanks to Chuck, to Josh, to Klaus. Josh and Klaus are here somewhere today. Thank you. Mo, Kavita, and Patty. So thanks to them, yeah.
And I think we're getting kind of hungry, so here is some takeout. Here's what we want to leave you with. First of all, working in the field of design system requires a blend of skills. You need design chops, engineering skills, communication skills, and operational thinking. If you want to be good at this and other types of projects, pay attention to all of these areas at the same time. You gotta see the matrix.
So for projects like this, it's really crucial to define success and get buy-in from your stakeholders, as we talked about. In an organization with no design system, but maybe a very mature product code base, adoption can be challenging, and it's gonna be more complex than just the building part. So stakeholders, and especially leadership, might not be aware of that, so try to help them understand what you're dealing with.
As you're scoping any large transformation effort, invest in building tools to help you visualize the problem. Code observability is an interesting field that has a lot of opportunity. It's really useful to have these kinds of tools available after companies scale. Also talk to the folks who went through that scale up and try to learn from their experiences.
It's really essential to develop a very thorough migration plan. So telling stakeholders what the end goal is, but not equipping them with the tools is not gonna work. So to help them get from point A to point B confidently, do it by putting together things like migration guides and other tools to help.
Also, be ambitious, get creative. Imagine how you could get your big projects done faster. When you think operationally, you start to understand that tools like code mods are essential. Break out the excavators. Right now, there's a huge opportunity to use AI to facilitate this kind of work.
So even though these takeaways are based on what we learned through this specific project with design systems, our hope is that you can apply them beyond just design systems or UI components, but to really any sort of migration or large effort in this sort of similar environment to drive transformation of that system.
And that's it. Thank you so much for listening.
Thanks.